Hello, welcome to Venkat Varma Chemistry YouTube channel. I am Venkat Varma, your chemistry host and enthusiast. We are here to make JEE NEET chemistry preparation easier and more effective. Join us for the easy to understand shorthand videos, tips and tricks to ace your exams. In this session, we are going to learn PHENOLS complete revision. PHENOLS complete revision. Let's start our session. PHENOLS. Phenols is known as carbolic acid. Phenols is known as carbolic acid. See, let's move on. General methods of phenol preparation. The first one, chlorobenzene. From chlorobenzene. See, from the chlorobenzene, in the presence of sodium hydroxide. See, chlorobenzene in presence of sodium hydroxide at 623 Kelvin and 300 atm temperature to give sodium phenoxide. It is acidified in presence of HCl. It gives phenol. This process is known as Dow's process. The name of process is a Dow's process. It is a phenol. Yes, it is a sodium phenoxide. It is a chlorobenzene. Let's move on. Second method. From benzene. Benzene oxidation with the in presence of vanadium pentoxide V2O5 at 300 degrees Celsius. It gives phenol. Benzene oxidation with the in presence of vanadium pentoxide, it gives phenols. Again, benzene in presence of oleum. What is the formula of oleum? H2S2O7. Oleum. It gives benzene sulfonic acid. Benzene sulfonic acid in presence of sodium hydroxide. Benzene sulfonic acid in presence of sodium hydroxide. It gives sodium phenoxide. Sodium phenoxide. It is treated with HCl. It gives phenol. It is a acidification. Yes, this process is sulfonation. Yes, let's move on. Next method from cumene. Cumene means isopropyl benzene. So how they form isopropyl benzene? See, benzene in presence of propene. AlCl3. It gives isopropyl benzene. It is isopropyl benzene. This isopropyl benzene oxidation in presence of O2. This is a O2. So when break down carbon free radical and hydrogen free radical, here oxygen bond is break down to form a phenol, to form a oxygen free radical. This O2 insert in between hydrogen to form a cumene hydrogen peroxide. It is a cumene hydrogen peroxide. cumin hydrogen peroxide in presence of, it is in the presence of sulfuric acid, in the presence of sulfuric acid, or in presence of H plus. What happened? See the OH. This bond is shifted to oxygen. OH. OH attack on benzene to form a phenol. To form a phenol and acetone. Phenol and acetone. It is also preparation of acetone method. It is also preparation of acetone method. Yes, it is from cumin. Cumin to phenol oxidation. Decomposition in presence of H plus to give the phenol. Yes, let's next method is from Grignard reagent. Grignard reagent. See chlorobenzene or bromobenzene. I am taking bromobenzene in presence of magnesium dry ether. In presence of magnesium dry ether to form a phenyl magnesium bromide. To form a phenyl magnesium bromide. Phenyl magnesium bromide in presence of O2 in dry ether. O2 in dry ether to form a OMGBr. Yes, it is in presence of H2O to give phenol. To give phenol. It is from Grignard reagent. It is from Grignard reagent. Let's move on. Next method. See, ratching process. What is ratching process? See, benzene in presence of HCl, in presence of hydrochloric acid and oxygen, in presence of copper chloride at 250 degrees Celsius, it gives chlorobenzene. It gives chlorobenzene. Chlorobenzene in presence of steam. In presence of steam at 425 degrees Celsius, it gives phenol. It gives phenol plus hydrochloric acid. It is a ratching process. Yes. Let's move on. Next is a decarboxylation. Decarboxylation is a in presence of soda lime. See, orthohydroxybenzoic acid. It is a orthohydroxybenzoic acid. Yes, in presence of soda lime, NaOH plus CaO. It is a soda lime. It gives phenol and sodium carbonate. Phenol and sodium carbonate. It is a decarboxylation method. What is the next method? From benzene disonium chloride. So what is how they form benzene disonium chloride? See, benzene in presence of NaNO2 plus HCl in presence of 0 to 5 degrees Celsius. It gives benzene disonium chloride. Benzene disonium chloride. Yes, the benzene disonium chloride just warm with water or heating with water, it form phenol. It form phenol. This is the method for preparation of phenol from benzene disonium chloride. Let's move on. Last method, Dakin reaction. What is Dakin reaction? See, orthohydroxybenzaldehyde. See, let's move on. It is a orthohydroxybenzaldehyde. Orthohydroxybenzaldehyde in presence of hydrogen peroxide H2O2 and NaOH. Hydrogen peroxide and sodium hydroxide. Hydration, it gives catechol. The aldehyde is converted to alcohol. It is a catechol. It is a catechol. It is a orthohydroxybenzene. 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 So next one, orthoaminobenzene in presence of H2O2 and sodium hydroxide. Hydration, it gives what? Aldehyde is converted to alcohol. Orthoaminophenol. Orthoaminophenol. Yes, orthoaminobenzaldehyde. In presence of H2O2 and sodium hydroxide, it gives orthoaminophenol. These are the general methods of preparation of phenols. Let's move on. Next important topic is a very most important topic is a properties of phenol. That is the acidic nature of phenol. Acidic nature of phenol. Let's move on. Let's move on. Acidic nature of phenol. Generally, phenol is a weak acid. Phenol is a weak acid. Yes, the acidic nature of phenol, the formation of stable phenoxide ion. Yes, phenol to form a phenoxide ion, to form a stable phenoxide ion. It shows the acidic character. Yes, this phenoxide ion is stable by resonance. Stable by resonance. Yes, stable by resonance. Due to resonance, it shows acidic character. Now, phenol has acidic character due to formation of phenoxide ion. The phenoxide ion is stable by resonance. Yes, let's move on. Phenoxide ion. See, I am writing if phenol reaction with metal. Phenol reaction with metal. What happened? See, I am writing phenol. It is a phenol in presence of sodium metal. What happened? To form a sodium phenoxide. Yes or no? Sodium phenoxide. To release the half H2. To release the hydrogen gas. Phenol does not decompose sodium carbonate and sodium bicarbonate. Phenol not decompose the sodium carbonate and sodium bicarbonate because phenol is weak acid than carbonic acid. See, very important point. Phenol is not decompose sodium carbonate and sodium bicarbonate because of phenol is weak acid. Phenol is weak acid than carbonic acid. Let's take example. If phenol is reaction with sodium hydroxide. See, next is a reaction with sodium hydroxide. What happened? Phenol in presence of sodium hydroxide. What happened to form a sodium phenoxide? Yes, to form a sodium phenoxide and to produce the H2O. Yes, the sodium phenoxide, it is a strong acid. The formation of water is a weak acid. The formation of water is a weak acid. So, how to check whether the reaction is possible or not? In the formation of reaction, the right hand side of the product to form a weak acid, it possible the reaction. Right hand side reaction is the right hand side, the product is a weak acid, it possible the product. Yes, it form forward direction. The reaction is possible. Let's move on. I am taking example. Reaction with NaNH2. Sodamide. NaNH2. What happened? Look at first. See, phenol in presence of NaNH2. Sodium phenoxide. See, sodium phenoxide. Sorry, NaNH2 to form a sodium phenoxide. to form a sodium phenoxide to produce ammonia. To produce ammonia. See, phenol is a strong acid. The formation of right hand side is a weak acid. Weak acid. The reaction is possible. Reaction is possible. Yes. Now let's take a reaction with sodium bicarbonate NaHCO3. I am writing reaction with sodium bicarbonate. Phenol. See, this is the phenol with sodium bicarbonate. See, sodium bicarbonate. What it forms? It forms sodium phenoxide. Yes, sodium phenoxide and H2CO3. H2CO3 carbonate. Yes, phenol is a weak acid. The carbonic acid is a strong acid. Already I am giving the concept. What I am giving? What I am giving? See, phenol is not decomposed Na to CO3, NaHCO3, because phenol is a weak acid. Phenol is a weak acid. See, reaction with sodium bicarbonate to form a H2CO3 is a strong acid. So it is a reversible reaction. Yes, reaction is not occur. This reaction is not occur. Not possible the reaction with sodium bicarbonate. Because it is a weak acid, it is a strong acid. Right hand side is a strong acid. It is not possible. No reaction. Reaction is not possible. Reaction is not possible. Yes. Let's take one more example. Para-nitrophenol react with sodium bicarbonate. It gives sodium phenoxide. Para-nitrosodium phenoxide. Phenoxide with the H2CO3. In this, para-nitrophenol is a strong acid. H2CO3 is a weak acid. Yes, the reaction is possible. The reaction is possible. Next, phenol with sodium bicarbonate to form a sodium phenoxide C6H5O minus Na plus to release H2CO3. Yes, the phenol is a weak acid. H2CO3 is a strong acid. Yes, phenol is a weak acid than carbonic acid. So the reaction is not possible. The reaction is not possible. No reaction. No reaction with sodium bicarbonate. Yes, let's move on. Acidic strength of phenol. See, acidic strength of phenol. See, acidic strength of phenol. See, phenol acidic strength is directly proportional to minus inductive effect, minus mesomeric effect, and inversely proportional to plus inductive effect and plus mesomeric effect. Yes, acidic strength is directly proportional to minus inductive effect and inversely proportional to positive inductive effect and positive mesomeric effect. Yes, let's take an example. See, it is orthonitrophenol, metanitrophenol, and paranitrophenol. See, NO2 at ortho position, NO2 is a meta position, NO2 is a para position. Yes, so NO2 is a minus inductive and minus mesomeric effect. Yes, it is a minus inductive effect, it is a minus mesomeric effect and minus inductive effect. See, negative inductive effect is directly proportional to acidic strength. See, in these two, it possible intramolecular it possible intramolecular hydrogen bond. Yes, it forms intermolecular hydrogen bond. Intermolecular hydrogen bond. See, compare these two. Para is more acidic than although after that meta. POM. The acidic strength is para is greater than ortho and meta. So I am giving number. The most is 3, after that 1, after that 2. Yes. Now coming to next question. See, it is a 1, 2, 3. So propanol, it is a 2, 4, 6 trinitrophenol and metanitrophenol. So it has what? The second one has 3 negative inductive effective group, electron with a dry group. ASSAM, it has only one, it has 3, 1, 2, 3. ASSAM, so it has minus mesomeric effect, minus inductive effect. It form only inductive effect, which is higher. Second is higher. After that what? Third. After that first. It possible positive inductive effect. Yes. Next. See, generally phenol is more acidic than alcohol. Why? Phenol form phenoxide ion. It is stabilized by the phenoxide ion. Yes. Next question. See, it has 2 NO2 groups. Okay. Here there is no group. It is a positive inductive and positive mesomeric effect group. NO2, it has 2 electron with a drying group, which is most obviously first one. After that, it has no groups. There is no donating group, there is no withdrawing group. So after that, positive inductive effect, it decreases. 1 is greater than 2 is greater than 3. This is the acidic strength. Next is the esterification. What is esterification? See, phenol in presence of carboxylic acid or COOH, it forms RC double bond O pH. Yes, RCO plus OH minus. Yes. Next, phenol with acyl chloride. It is also formed RC double bond O pH. Phenol with acetic anhydride RC double bond O C double bond O R. Yes, it is also formed RC double bond O pH. Dissolved with acid to form a ester is a esterification in presence of H plus. To form a ester. Yes, let's move on. Next one, Rimmer-Tiemann reaction. This is important. Rimmer-Tiemann reaction. What is Rimmer-Tiemann reaction? See, phenol in presence of chloroform CHCl3 with sodium hydroxide or potassium hydroxide, to form a sodium phenoxide. It need what? 60 degrees Celsius. And in presence of H plus, it gives orthohydroxybenzaldehyde. And parahydroxybenzaldehyde. It is a salicylaldehyde. Yes, salicylaldehyde. See, ortho product. It is a para product. Ortho product is a major product. In this, Ortho product is stabilized by chelation to form a chelation. Ortho product to form a chelation. Yes, it is stabilized by chelation. Next, it undergoes electrophilic substitution reaction. It undergoes electrophilic substitution reaction. Yes. Now look at for mechanism. What is the actual mechanism involved in Raymer-Tiemann reaction? See, sodium hydroxide, potassium hydroxide, it produce base OH minus in presence of chloroform CHCl3, in presence of CHCl3. Yes, what happened? It abstract proton to form a CH2O plus CCl3 minus. When it is heated, it becomes CCl2 and Cl minus. It is a dichlorocarbon. Dichlorocarbon is a neutral electrophile. It is a neutral electrophile. Dichlorocarbon is a. See, this neutral electrophile attacks on, see, right, sodium phenoxide. Phenol to form a phenoxide ion. Phenoxide ion with dichlorocarbon CCl2. Yes. So this negative bond is shifted to benzene ring, and this pi bond getting negative charge, it attract CCl2 to form a Cl. This is one. See, when bond is shifted to this side to form this CCl2 becomes O minus and a CHCl2. So this CHCl2 in presence of OH minus, it forms what? See, O minus. So the chlorine is substituted by OH. Yes, to form a diol. It is unstable. It loses water to form a CHO. Yes, when it is treated with H plus to form a ortho hydroxy benzaldehyde or salicylaldehyde. This is the mechanism for Raymer-Tiemann reaction. Yes. Next, see, I will look for question. See, which of the following undergoes Raymer-Tiemann reaction? Which of the following undergoes Raymer-Tiemann reaction? I am writing example. It is phenol. Yes, phenol and phenol with CH3O. Yes, and third one nitrobenzene. Fourth one benzene. So which of the following substrate involved in Raymer-Tiemann reaction? So which is formed phenoxide, which is formed sodium phenoxide, that can involve the Raymer-Tiemann reaction. See, when it is treated with sodium hydroxide, it forms sodium phenoxide 8. It forms sodium phenoxide. Yes, when it is treated with sodium hydroxide to form a sodium phenoxide. Yes, sodium phenoxide. So these two are not from the sodium phenoxide. So these are not undergoes the Raymer-Tiemann reaction. Only these two are involved the Raymer-Tiemann reaction. Yes, let's move on. Next reaction, Kolbe-Schmidt reaction. Kolbe-Schmidt reaction or Kolbe's reaction. Phenol. See, phenol in presence of sodium hydroxide to form a sodium phenoxide with the carbon dioxide at 125 degrees Celsius 125 degrees Celsius at 6 atm pressure to forming C. COO Na plus. Yes, in presence of H plus, it forms orthohydroxy benzoic acid or salicylic acid to form a salicylic acid. Yes, CO2 act as electrophile. CO2 act as electrophile. Yes, let's move on. What is a cool base reaction mechanism? What is a mechanism? Look at for mechanism. See, sodium phenoxide. Yes, sodium phenoxide with the carbon dioxide CO2. Yes, when the negative charge shifted to benzene ring. Yes, this carbon pi bond shifted to oxygen. This pi bond is attracted to form a C. C double bond O in a plus. Yes. Next, it is tautomerize. It is tautomerize. When it is treated with H plus to form a orthohydroxybenzoic acid or salicylic acid. The Kolbe's reaction is used for the preparation of important derivatives in medicines. See, orthohydroxybenzoic acid. It is a orthohydroxybenzoic acid or salicylic acid. See, it reaction with methanol CH3OH in presence of H plus. It forms what? See, this is the product OH. Yes, COOCH3. It is a methyl salicylate. It is a methyl salicylate. Methyl salicylate is the oil of wintergreen. Oil of wintergreen. It is the oil of wintergreen. Methyl salicylate. When salicylic acid treated with C6H5OH phenol to form a C COOC6H5. It is formed phenyl salicylate. It is a phenyl salicylate. Phenyl salicylate. It is a salol. The name of medicine, the name of the compound is a salol. When it is treated with acetic anhydride CH3, C double bond O, C double bond O, CH3. What is the product? It forms acetyl salicylic acid. Yes, O, COCH3. Yes, COOH. It is a aspirin. Acetyl salicylic acid. It is a acetyl salicylic acid. This is the importance of orthohydroxybenzoic acid. Let's move on. Electrophilic substitution reaction. See, electrophilic substitution reaction. See, electrophilic substitution reaction. The first one is the bromination. The first one is the bromination. See, phenol in presence of bromine, 3Br2 in aqueous medium, it gives, see, this is the product 2, 4, 6 tribromophenol. 2, 4, 6 tribromophenol. Tribromophenol. Yes. When? Next one. Next is a nitration. What is the nitrating mixture? HNO3, H2SO4. See, the first condition is dilute HNO3. The first condition, dilute HNO3. I am writing phenol in presence of NO2. It is a nitronium ion. Electrophile. It forms orthonitrophenol and paranitrophenol. Orthonitrophenol and paranitrophenol. Orthonitrophenol, it undergoes intramolecular hydrogen bond. It follows intermolecular hydrogen bond. It forms intramolecular hydrogen bond. It forms intermolecular hydrogen bond. See, their boiling point is for example, it is A, it is B. So B is greater than A. Volatility is B is less than A. B is less than A. If phenol with concentrated HNO3, what form? It form of 2, 4, 6 trinitrophenol. Yes, it forms 2, 4, 6 trinitrophenol. It is a picric acid. Yes. Next, phenol with Br2, bromine in carbon tetrachloride, in carbon disulfate. It gives orthobromophenol and parabromophenol. Yes. Let's move on. Next. See, sulfonation. Next is the sulfonation. Very simple. Benzene in presence of concentrated H2SO4 is at 20 to 25 degrees Celsius. It gives ortho product. Yes. When it is treated with the concentrated H2SO4 in presence of 100 degrees Celsius, it forms para product. It is a ortho product. It is a para product. Yes. Next is a Buchanan reaction or reaction with ammonia. Phenol reaction with ammonia in presence of anhydrous zinc chloride. So ammonium sulfate, ammonia at 150 degrees Celsius, it gives aniline. That is the Buchanan reaction. Phenol with ammonia, anhydrous zinc chloride with ammonia at 150 degrees Celsius to give aniline is a Buchanan reaction. Yes. Next, benzylation. Yes. C6H5OH phenol. C6H5COCl. Acyl chloride in presence of sodium hydroxide to form a C6H5OCO C6H5. It is a shorten bond reaction. Yes. Let's move on. Next, coupling reaction. It is important. Coupling reaction. See, phthalic anhydride. It is a phthalic anhydride with 2 moles of phenol. It eliminates the water. It gives phenolphthalein. So phenolphthalein is colorless in acidic medium, pink color in alkaline medium. pink color in alkaline medium. It is a coupling reaction. Coupling reaction. Yes, toluene anhydride with 2 moles of phenol in presence of H2SO4 to form a phenolphthalein. So colorless in acidic medium, in pink color in alkaline medium. Yes, next. See, oxidation. Next is the oxidation. So in oxidation, ELBS persulfate, ELB sulfate oxidation. Phenol, phenol with K2S2O8. In alkaline medium, it gives quinol. It gives quinol. Yes, it is a 1, 4 dihydroxybenzene. It is a 1, 4 dihydroxybenzene. Yes, it is a quinol. Next, phenol in presence of air oxidation, CrO2, Cl2, chromyl chloride, it gives parabenzoquinone. It gives parabenzoquinone. It is a parabenzoquinone. Yes, parabenzoquinone. Let's move on. Let's move on. Look at the question. Phenol with the sodium hydroxide CO2 pressure, it gives A. In presence of H plus, it gives B. In presence of acyl chloride, it gives C. Acetyl chloride, C. Phenol with the sodium hydroxide. Sodium hydroxide. Yes, it forms what? In presence of CO2, it forms COONaOH. Yes, in presence of H plus, it forms what? COOH plus OH. In presence of acetyl chloride, CH3COCl, it forms what? Aspirin, COOH and OCOCH3. It is a aspirin, acetyl salicylic acid. Acetyl salicylic acid. I will look for next question. See, benzene with OH with CH3 in presence of CHCl3KOH. It is a Reamer-Timmer reaction. Very simple, to form a orthohydroxybenzaldehyde. Yes, to form a orthohydroxybenzaldehyde. In presence of lithium aluminum hydride, what happened? Reduction. It convert alcohol. It convert alcohol, CH2OH. Yes, when it is treated with, see, what is a reagent acetic acid in presence of H plus, it forms what? See, it forms benzene with O, C double bond O, CH3 and CH2OH and CH3. It is A, it is a B, it is a C. Okay, have a look for next question. Benzene with C, 2-chloropropane. See, I am writing benzene with CH3CHCl. So it forms what? CH3CH3. It forms what? Cumene is formed. Isopropyl benzene is formed. Yes, isopropyl benzene in presence of oxidation. What formed? It forms C, OOH, CH3. It forms, and again it is treated with H plus. It forms what? Phenol and acetone. phenol and acetone. Yes, phenol with Br2 in carbon disulfide. What formed it from? Ortho, ortho, orthobromophenol and parabromophenol to form a orthobromophenol and parabromophenol. Yes, again phenol with this one Na2Cr2O7 and H2SO4. It forms what? It forms, see, it forms benzoquinone. It forms benzoquinone. Yes, yes, this is a good revision for phenol. See, I hope you like this video. Don't forget to share and don't forget to give like. If your content is valuable, make sure to subscribe our channel. Yes, and hit the bell icon to stay updated with the latest videos and notification. Yes, thanks for watching.